this is the final exam review. You will be able to use your review on your final exam, so you need to write down as many notes as you can, and you also need to make sure you don't forget to bring your review on the day of the test. Okay? The first thing we're going to be looking at is finding inverses. So for problem number 1, we have f of x equals 4x plus 16. To do this, to find this inverse, usually I would go ahead and change f of x to y, just because I think it makes it a little bit, shorter. To find inverses, you're just taking the x and you're taking the y and you're switching them. So I'm just going to rewrite this as x equals 4y plus 16. So that's the first step, switch the x and the y. And then from here, we have to get y by itself again to make it back into a function. So we're going to subtract 16 from both sides. So that gives me x minus 16 equals 4y. And then I'm going to divide both sides by 4. So my inverse is x minus 16 over 4. All right, number 2. We have f of x equals the square root of x minus 4 plus 5. So the same thing here, f of x is the same thing as y. I'm going to switch the x and the y, so x is going to equal the square root of y minus 4 plus 5. So the first step was to switch it, and now we have to get y by itself. So to do that, I'm going to subtract 5 from both sides. So that gives me x minus 5 equals the square root of y minus 4. And now to get y by itself, I need to get rid of the square root symbol. So I'm going to square this side, and I'm going to square the other side. So now what I have is the square, parentheses, x minus 5 squared equals y minus 4, because the square canceled the square root. And the last step is just to add 4 to both sides. So my answer is y equals x minus 5 parentheses squared plus 4. Now for question 3. F of x equals x squared minus 5. On the last problem, we saw that a square root changes to a square when you do its inverse. And so now that we have a square, it should end up with an answer that has a square root. Remember that x squared and the square root of x are actually inverses of each other. So if you start by changing the f of x to a y, then we're going to switch the x and the y. So this is going to be x equals y squared minus 5. Then from here we just need to get the y by itself. So I'm going to start by adding 5 to both sides, which is going to give me x plus 5 equals y squared. So now to get y by itself, I need to get rid of the square, the power of 2. So I'm going to square root to get rid of the square, and I'm going to square root on the other side also. So this will be the square root of x plus 5 equals y, because the square and the square root cancel each other out. So that is the inverse. Notice that x squared, when we found its inverse, we got an answer with a square root. Number 4. One more inverse problem. The only difference in this problem from number 1 is just that this one has a fraction. And sometimes fractions confuse people. So we're going to change the f of x to a y. And then I'm going to switch the y with the x. And then I have to get y by itself. So I'm going to start by subtracting 4. X minus 4 equals 1/3 y. Now to get y by itself, I need to get rid of the 1/3, so I have to multiply by the reciprocal of 1/3, which is 3. I'm going to do that on both sides. So 3 times x minus 4 becomes 3x minus 12. And this 3 cancels with this 1/3 and just leaves us with y. So y equals 3x minus 12 is the inverse. Question number 5 is factoring. So now we're going to take a polynomial, in this example specifically, it's going to be a quadratic, and we're going to factor this. So since there is nothing in front of x squared, all we have to do is say what multiplies to give me negative 10 and adds to give me negative 3. So negative 10 could be negative 5 times 2, or it could be negative 2 times 5, or negative 10 times 1, or negative 1 times 10. So we're looking for what adds up to negative 3, which is going to be right here. Negative 5 and positive 2. So the factors will be x minus 5 and x plus 2. Going on to number 6. This problem does have a leading coefficient. The first number in this problem is 15. So we have to do some extra steps to get this to work out. So the first thing we're going to do is we're going to take the 15 and I'm going to multiply it to the end. So that's going to change this problem to be x squared plus 14x plus 15 times 3, which is 45. Now I want to factor it like I normally would, so I'm going to see what multiplies to give me 45 and adds to give me 14. So 45 is 9 times 5. So if I do x plus 9 and x plus 5, 9 plus 5 adds up to 14 right here. And 9 times 5 equals 45 right there. So that's the factor, but the very first thing we did was multiply by 15, so now what we're going to do is divide by 15. We're taking the 9 and dividing it by 15 and taking the 5 and dividing it by 15. And I'm going to simplify these. So this is x plus 9 over 15 reduces to be 3/5. And 5 over 15 reduces to be 1/3. And since neither of those are whole numbers, I'm going to take the denominator and I'm going to squeeze it in front of the x. So that makes this be 5x plus 3 and 3x plus 1. All right, now let's look at number 7. This is x squared minus 25. In chapter 8, I believe it was, we talked about how this is the difference of two squares. But when we initially factored this, I used to rewrite it. So let's rewrite it to make sure you can see. This is really the same thing as x squared plus 0x minus 25. So if you think of it that way, we're looking for two numbers that multiply to give me negative 25 and add to give me 0. So if I do my two factors, I'm going to have x and x. And 25 could be 5 times 5. So 5 times 5 is 25. If I make one of them addition and one of them subtraction, then positive 5 and negative 5 do add up to be 0. And positive 5 times negative 5 do multiply to be negative 25. So this is the answer. Now if you're looking at this in terms of a shortcut, once you see that it's something squared minus something else squared, so x squared minus 25, we know it's going to be two groups. X squared would be x times x. 25 would be 5 times 5, because 5 is the square root of 25. And then you make one of them plus and one of them minus, and that's the shortcut, which not that big of a deal. We didn't do that much different. All right, one more factoring problem, number 8. This problem only has two terms, 14x squared minus 21x, and this is not a perfect square because 14 is not some number squared, and this is not a perfect square. So if we only have two terms and they're not perfect squares, then we're going to look for the greatest common factor. So I'm going to look at 14 and 21 and decide what do they have in common. So 14 and 21 are both divisible by 7. And then I'm also going to look at the x squared and the x and see what they have in common, and they both have at least one x. So if I take the 7x out, I'm putting it in front of the parentheses. So basically I'm dividing by 7x, I'm dividing by 7x. So if I took 14x squared and I divided by 7x, that would leave me with 2x. And if I took 21x and divided by 7x, that would leave me with 3, and the x's would be completely canceled. So this factors to become 7x times 2x minus 3 as a group. Number 9, we have square roots and we're going to be solving. So 9, 10, and 11, we're going to have a square root in the problem. And we're solving this for x. So we're trying to get x by itself. So looking at this problem with the square root of x plus 8 equals 10, the first thing I would have to do is subtract 8 from both sides, because once I subtract the 8, I have the square root of x equals 2. So this square root is by itself, and that's kind of my goal. Once I get the square root by itself, then I can take my next steps. So to get x out of the square root, I'm going to square this side, because that's the opposite, which means I'm also going to square this side. When you square a square root, it leaves just x by itself, and when you take 2 and you square it, you get 4. Alright, number 10, we have the square root of x plus 8 equals the square root of 2x plus 4. It doesn't matter which side you start with on this one, because both of them have the square root. We have to get rid of that square root symbol. So I'm just going to go ahead and square this side, which means I have to go ahead and square the other side. And when I square the square root, it leaves x plus 8. And on the other side, when I square the square root, it leaves 2x plus 4. Once the square root symbols are gone, this is back to being basically a normal equation. We're just trying to get x. So I'm going to bring the x's together, so I'm going to subtract x from both sides, and that will leave me with 8 equals x plus 4. And then I'm going to subtract the 4 from both sides, and I get 4 equals x. It's not a bad idea to go ahead and check to see if these work. For example, if I plugged 4 in for this x right there, this would have been the square root of 4 plus 8. So that would be the square root of 12. And then on the other side, if I checked it, that would be the square root of 2 times 4 plus 4, which is the square root of 8 plus 4, which is the square root of 12. And so since these two things are equal to each other, then we know that it all works out. All right, going on to number 11. For a lot of people, this is the type of problem that gives them the most difficulty. We'd like to get the x's together, but on this side over here I have a square root. So I have to start off by getting rid of that. So to get rid of the square root, I have to square it. And if I square that side, I have to square both sides. So squaring the square root on the left side leaves me with x plus 1. But squaring 2x plus 1 means 2x plus 1 times itself. That's what it means to square something. So since we have to do 2x plus 1 times 2x plus 1, that means we're going to have to FOIL. So that's going to be x plus 1 on the left equals 2x times 2x plus 2x times 1 plus 1 times 2x plus 1 times 1. So first times first, outside times outside, inside times inside, and last times last. So this is x plus 1 equals 4x squared. I have 2x twice, so that's going to be 4x plus 1. Now my goal is still the same as it was before. I'm still trying to get x by itself. So I've got to bring these things over here to the other side because I need one side to be equal to 0. So to do that, I'm going to subtract x from both sides. I'm actually going to write that in a different color. And then I'm also going to subtract 1 from both sides. And I just go ahead and line it up to where the x is with the x and the 1 is with the 1. So on the left side now we have 0. And on the right side I have 4x squared. This is going to be plus 3x. And then plus 1 and minus 1, that cancels out. So this starts to feel kind of like a long problem, but we're really almost there. We just need to factor this 4x squared plus 3x. So since it's just two terms, and they're not both perfect squares, we're going to check to see if there's a greatest common factor. So we look and see that 4x squared and 3x both have an x. So if we take one of those x's and put it in front of the parenthesis, then I'll be left with 4x plus 3. So now I have two solutions. Either this x is equal to 0, that's one of my solutions, or 4x plus 3 is going to be equal to 0. So in that case, if I had 4x plus 3 equals 0, Then we would solve this by subtracting the 3. So now I have 4x equals negative 3. And divide by 4. So now my second solution is x equals negative 3/4. The last thing you should do for this type of problem is check your answers. And if I plug 0 in, it checks out that there's not a problem. But if I plug in negative 3/4, you'd have to go back in and plug it in. So if I plugged it into this original problem up here, the purple, in the 2x plus 1, what's going to happen is that I'm going to end up with the left side is going to be positive 1/2. But when I plug negative 3/4 into this right side, I get negative 1/2. And positive 1/2 and negative 1/2, although they're both halves, they're not the same because they're not the same sign. So this part right here, this x equals negative 3/4, would be an extraneous solution. Basically, that just means it looks like it's a solution because we worked it out, but when we plugged it back in, it didn't quite work. If you forgot that on your test, it probably wouldn't hurt you that much, but since it's going to be multiple choice, you're probably going to find that there will be an answer choice that's got extraneous solutions. So just make sure you got that down so that you can keep an eye out for that. Okay, that's the end of the square root solving equation part. 12, 13, and 14 we're going to be graphing, and we're graphing rational functions. Rational means that it has a fraction in it. Or specifically, it's a fraction where the variable is in the denominator. So if we take f of x equals 1 over x plus 3 minus 2, then we're going to be, this is actually a graph where we're going to be shifting. So remember that x plus 3 being the denominator, technically you can think of it as having parentheses because it's grouped together, the x plus 3 is. So this has been shifted left 3 because anything in parentheses, remember, is going to go the opposite direction. And then the minus 2 at the end is going to be a shift of down 2. So when I graph this, what that's going to mean is that instead of starting at 0, 0, I'm going to start left 3 and down 2. So 1, 2, 3, 1, 2. That's going to be my center point. The other thing you kind of have to remember about this is what it's going to look like. Anytime you have a function that has this general setup, it's going to look like two lazy L's. So where I have this dot over here, that's my center, I'm actually going to draw dotted lines because I'm going to have asymptotes. Alright, so hopefully you'll kind of remember how we graph this. If you start at your center and you go up 1 over 1, which is right here, then I'm going to draw my lazy L coming through that point right there. And starting from my center, I'm going to go down 1, back 1, which would be over here, kind of far. And I'm going to draw a lazy L that goes through that. So that's going to be my rational equation. For number 13, our graph is f of x equals negative 1 over x minus 1 with plus 1 at the end. So the negative is kind of like your slope, and the negative tells us it's going to be a reflection. So that means that our lazy L's are going to be in different directions than they usually are. Then for x minus 1, that means we're going to have a shift right one place. And then, excuse me, then plus 1 at the end means we're going to shift up one place. So if I graph this, then I'm going to start off by shifting right 1 and up 1. So 1, 1 is going to be my center. And I'm going to make my dotted line. The dotted lines help me guide where to graph this. Now, since it's reflected, instead of going up 1 and over 1 from my center, I'm going to go down 1 over 1, which is going to be over here. So when I draw this lazy L through here, it's going to be on that side. So then when I go the opposite direction over here and draw that lazy L, it's going to be like that. Let's look at 14, the last one to graph. That's f of x equals 2 over x plus 4. I'm going to write it as 2 times 1 over x plus 4. I like to rewrite it that way because then you can see a little bit more specifically that the 2 is going to do something to your equation. And what it does is it causes the equation to be stretched. Basically, my slope now is going to be up 2 and over 1, so it's kind of a stretch. 1 over x, there's not any shifting right or left. And then plus 4 means up 4 places. So, I'm going to start off at the origin, but I'm going to go up 4 places. That's going to be my center point. So that's where I'm going to make my asymptotes. The vertical asymptote is just going to be the y-axis. So from my center, instead of going up 1 over 1, we're going to go up 2 over 1. Draw the lazy L. And then from the center, I'm going to go down 2, back 1, just to make sure that it's opposite. And those will be my 2 graphs.